So thank you very much for having me. It's really a pleasure. And so this is joint work with Richard Stanton, Carlos Vergara, and Paulo Eisler. And so I think you've read in the newspaper enough that we have a serious problem in California. And unfortunately, it got even more serious last Wednesday. You might have missed the news. But we've had two insurers that have been very reluctant to do new policies. And as of Wednesday of last week, State Farm announced that they are going to cancel 42,000 commercial insurance policies and 30,000 residential insurance policies in the next 4 months. So this is a huge insurer, for one of the most largest in the country, and it's a very important insurer for California, but these risks are too large for insurance companies to cover, even though California has unique problems that were a function of the way we regulate insurance companies. The risk is much more broad in terms of the exposures that are here and what insurance companies can and cannot manage. And that's basically the point. And I'll talk about some of the other work we're doing based on this now that is trying to measure and use climate data and real estate data and put it together so we can actually get our head around this risk. So the purpose of this paper is to look at post-wildfire house price and size dynamics. So what happens with insurance coverage of houses in California after fires? What are the effects on the mortgage market? And what are the effects of gentrification? And most of the other climate risk areas, we see a lot of gentrification after events. We see a big change in the population. And so that's one of the questions of whether that's also true here. And then we also want to quantify what these exposures are. And ultimately, our goal here is pricing, although you're not going to see it in this paper. That is where we're going now, of actually developing forecasting models to price. And this is an issue in California because that has not been allowed up until September of 2023. So we have a state which by legislation does not allow the use of actuarial models for pricing, which is very short-sighted, obviously. Well, maybe not so obvious. They think it's not obvious. So we're looking at a lot of data. So we basically gridded out the whole state, measured 2.5 mile distances for the entire state. And as you can see, these are the fires. And so they basically follow the coastal range, which is the lower range, but these are fairly steep hills. So there's on the edge facing the Pacific Ocean, and then also on the Sierra. And you can see there's quite a lot of correlation along these ridge lines. And so that's been a piece of what we're working on now, of forecasting models that can handle this correlation. And so that's part of the goal, where we really want to start pricing this, both not for mortgages, because those are 30-year out of sample, but for insurance products that are annuals. So one of the big issues that's different with wildfire risk is that it's what your neighbor does is going to affect your exposure. So there's a lot of correlation. These externalities are shared across neighboring properties, which is much less true for things like hydrological risks. If your next door neighbor is on stilts, it doesn't affect your risk necessarily. But with fire, it absolutely does. So if your neighbor doesn't clear up their lot and leaves a lot of timber lying on the ground, or doesn't mow their lawn and the grass can grow, a foot high or a meter high, you're going to be more at risk. And this has been a big issue in the state. And in some ways, this research is intended to address this externality reality of these fires and what it will take to change hearts and minds. And I personally think it's going to be a pricing system that actually gets the risks more clearly in front of the people that are exposed. So to sort of put a framework on this and to help with some of the results, which we'd struggled with, why we were getting some of these results. And as I go through, you'll see this more clearly, at least I hope so. So thinking about two houses, a simple problem. We have two homeowners, each owning one property. The housing services are obtained from owning the house and as well as in improving it. And this is the classic reason why do we have slums that never get remodeled, and it's a classic prisoner's dilemma problem. So our total market value is of our market value of our house without externalities is a function of the value of the home plus a factor of proportionality for the neighborhood externalities. In this case, we just have two houses, and so for it's the neighboring externality house. So if we assume that the baseline parameters for the market value of the house is 66.6666, 67, and this factor of proportionality is 0.5, we can go ahead and set up this simple game and think about what goes on. So if neither homeowner invests, we have the lower right-hand cell and of $100 each. So again, reflecting these externalities. And if each of them invest, you can do the arithmetic, and they're both worth 108. And then the off diagonals, we get the 83, 125. And basically in this framework, neither homeowner would prefer to invest. They would prefer to invest, but neither does because the dominant strategy for them is to do nothing. And so that's where insurance becomes important. With insurance, you've already paid for the premium to get your home rebuilt, and it is the insurance company that is paying for that rebuild. And these are quite extreme. So these are, for many of years, we had guaranteed replacements. So literally we're replacing every nail, exactly the same type of nail, exactly the same wood, and everything else about the house is replaced. Okay, so now the cost of replacing the home is not paid by the homeowner, it's paid by the insurance company. And so now in this world, in these fires, one thing for all of you that don't live in California to understand is that when these fires happen, these are hurricanes of fire. There are no houses left. So literally the rebar supporting these houses is melted. There are no roofs. And so the destruction rates in some of these fires are more than 80%. There's a total loss of the homes. They're scoured to the earth. And so the world in this place, if nobody rebuilds, the houses are worth nothing. So we're talking about the improvements here. And the improvement has been wiped off the ground. So if nobody invests, then it's going to be 0-0. And of course, if people do invest, and so now they've rebuilt the home, it has to be built to code in California. So the value of the houses, if both of them invest, because the insurance company is paying the $67, that position is 175 to 175. And then the off diagonals in this world are as shown. And so the fire has basically overcome the coordination problem, and the dominant strategy is for people to invest. And that's going to be reinforced legislatively. Yeah, go ahead, Arpa.
I guess I'm a little confused here because my prior would have been that the moral hazard force would be dominant, right?
Yeah, well, that's a great question. And the reason reinforcing this is in California, the way the laws, especially the property taxes, are written is they hugely incentivize to move back to the same place. So it has to do with two things: how the insurance is paid off. So the payout after a fire is that you can either get paid what the house was worth the day before the fire, net the value of the land, or you can rebuild the house with a full policy, usually with guaranteed replacement, at the new building code, and then they will pay for that, and then you move back in, but that will happen at the same address where the house was.
I don't understand how that addresses the moral hazard, though, I guess, because it still seems to me that if you're rebuilding the home exactly the same way, it seems like what I want to do is just buy the home, don't improve it at all, and just let the insurer take care of it if the fire happens.
That could happen, and the insurance is for the bank. So, I mean, the insurance policy is insuring the bank, the risk for loss, but the incentives are very strongly for you to maximize your policy to rebuild the house and then sell it. You'll get the maximum payout with that strategy.
But why are they investing in cutting the lawn and minimizing the?
Their risks. They're not. Nobody's doing that. So that's one of the big problems in California. No one's hardening their lots because they know if there is a fire, the insurance companies are going to basically 100% reimburse your loss.
That's the one.
Yeah.
Right. So it seems like fire insurance, insurance should reduce the incentive to invest.
Insurance, why would it reduce?
After the fire.
I'm talking about after the fire.
And can I ask another clarification question? When you talk about this investment, should we be thinking about people like mowing their lawn, which is not what the insurance company is for? Or should we be thinking about like investments that are home improvements where like the new house that I built has like fire resistant material?
Yeah, it's both of those things. So it's like cutting the limbs of your tree up 8 feet, putting like sand on the ground. I mean, what would it take to stop these fires? Putting on fire resistant roofs, putting on double pane glass. It's all of those things that are associated with hardening the lot. And nobody's doing that. Other than when it burns and then it's to the ground and then you get a brand new house to code that has all of these things, which are part of your policy that are reimbursed, but you have to move back to the same place on the ground.
More about like the yard is now designed in a way that it's less fire.
Yes, that's
This is
correct.
about it.
As is the house.
Mhm.
So it has double pane glass, it's got different kinds of roofing. It's much more resistant to fire.
But you said they built it the same way with the same nails, or are they building it exactly to spec as
They
it was
have-
before,
they
or are they
have-
building a new fire resistant?
They have to build code. So you have to build a
That'd
house.
be a-
Not quite the same.
It's not quite the same house, but it's got all the features it had before. Plus, it's got double pane glass and a fire resistant roof, and it has different landscaping, which are super valuable. So that's the problem. And the California state reinforces this by making it very difficult for people to move away from fired areas. Now that's changed there was a new proposition, we have them all the time, and Proposition 19 now allows people to move their fire, whatever the benefit would be for their improvement, to buy a house elsewhere. But often it's not quite enough because of the land issue. The land is really scarred, the value of the land really is less, and so it's hard again to make that actually work as a person that's just lost a house. Yes, go ahead, John.
Oh, when you talk about the full coverage or the replacement value, doesn't that depend on how much coverage you buy initially?
Yeah, it's true, but
Everyone
the
buys full coverage, is that right?
pretty much, the banks more or less force you to in California to basically insure up to the value of the loan. And so these are expensive houses, the insurance is very substantial, and it is the bank that's being insured. And the banks see that. You're just an agent, as a homeowner, you're just an agent of the bank. And the way the policies are written, the bank can actually intercede if they don't like the job you're doing in replacing the home.
Okay, so the banks don't just require to insure up to the mortgage amount.
Not usually. Yeah, sure, go ahead.
So is it guaranteed that in some sense you can rebuild in these areas? Because you would think, if you take a step back, no, as a realistic policy maker, it would probably be optimal to say like some areas that are very fire prone to just not.
Are not buildable anymore. Yeah, I agree with you, but that hasn't happened yet because I haven't told you this yet, but in California, they do not allow the use of actuarial models for pricing insurance. Those are the rules. And so it's led to horrendous incentives of putting houses in exactly the wrong place. And they're everywhere. And the cities, of course, depend on this because the way the cities expand are into these very dangerous areas, and because nobody has to price it, because the California Department of Insurance won't allow it. It's been a serious problem. Yeah.
Sorry, one follow up on this point, because what I've heard is that if you put, one house in a fire prone area, that's obviously bad for all these reasons. But if you actually just put a lot of homes there, you actually just cut down all the trees and then you eliminate the fire.
It's not
risk.
true, because a lot of this,
Why there's
if I
no
go-
fires in like LA, right? Like. they,
there are
like, cut
huge
down
fires
trees.
in LA, like Santa Monica
Yeah,
is
but
like,
like
oh,
the
what?
city of LA, like in your map, right? So if you like completely raise an area and develop it.
if your whole thing
Oh,
is,
the San
it's
Diego
not-
Mountains.
I agree, if you live in a parking lot, okay, the fire risks are pretty low. But the problem is the steepness. So the lots that are the most beautiful, that have the greatest views of the city, are on these slopes like this. And I'm going to show you, these slopes are incredibly dangerous because it has to do with the wind, the heat of the wind, and people like riding their dirt bikes through the grass. That's enough to start a fire. The second big channel right now are Tesla crashes. In your Tesla, when you have a crash like this,
Love it.
it bursts into flame. And so we've had 2 of the fires in Southern California were both Tesla crashes, and those were $17 billion fires. These are huge risks.
Elon Musk ought to be.
I mean, when the humidity falls on these fires in certain places, literally walking through the grass can start a fire, or driving your bike through, or doing, target practice on a hot day. Yeah, that's enough to start a fire. Anyway, so we saw that, just like the homework problem we gave our undergraduates, we now see, we have information about this problem and how these externalities really interact to give these results. And then we can also think about sort of the, neighboring areas of things that are abutting fires, where you have this replacement of the housing stock with this higher quality 2 code properties, that there might be externalities around fires that also are relevant in terms of what happens post-fire. And so this is a similar example, only now it's not that you burn, but you're abutting a fire and you're taking advantage of the externality of the rebuilding from the fire. And so again, even here, even though it's not the actual home that burns, this game also has a unique symmetric equilibrium with a probability of 0.35, that even abutting properties will remodel because the properties that they're close to have, and so everyone is benefiting from this coordination solution. Okay, so now we have fire insurance in California, which is a little bit unique. We're trying to fix this problem. So in a frictionless world, to Arpit's question, you might be indifferent from wildfires because you know that the insurance company is going to bail you out, and so you do nothing, and the policy, you are completely covered. And so it shouldn't have any effect on mortgage insurance because the homes are going to be rebuilt, and that benefits the banks. Of course, if there are frictions, and these fires are pretty significant, they're pretty traumatic, and they're wiping out your primary source of wealth. And in California, given the cost of housing, for most people, this is their wealth. And so what is the insurance covering? Well, the insurance, we just talked about this. If you want to get the coverage for exactly what your house was, you have to rebuild. So there's no net there. They rebuilt, they built a code. There are usually living expenses that are covered. Oh, another thing, only about 1% of people actually read their fire insurance policy. And I gave this paper at Stanford recently, and many of the people in the audience had just had their policies canceled, and they'd never read their policy. And this is probably true of most people in the United States. People don't read these things.
Have you read your policy?
I have, as it turns out, because my house burned.
Before this project?
No. So as I say, in California, you have to build a code. So you're by definition going to have a better house. And that's part of the policy writing. And then interestingly, the personality, what you own inside, not maybe very high expensive art, but nearly everything else is a residual on that policy. So it's what the total policy is, and then X% of that covers the personality. But you do not have to buy that. So those dollars are also often put into the house too, because people think they can forego like the next pair of nice clothing, shoes, jewelry, whatever, and then put it into the capital in the house. And so that part of the policy is fungible. And so basically there are these externalities, both coming from the code and also coming from the policies themselves. Okay, so this is basically what we're doing. So it's these are going to be different diffs, at least the first part of this. And so we have these fire areas, and this one was a very dramatic fire, but we have about nearly 700 of these in the data. This led to one of the largest movements of a population. About 1.3 million people were removed from this area. It burned nearly to the ocean. And as you can see, it involves a lot of properties. So some of these fires are burning thousands of homes, and it happens very quickly. So it's 1,000 homes in an afternoon.
What are the dots?
Those are houses.
Those are houses.
So these are houses. We're looking at the burn area is the orange, then the yellow is the first control, and then the very light yellow is the second control. And again, following our sort of framework of how this game works, of these externalities and how the fires give us this coordination mechanism post-fire. Okay, so it involves a lot of data. Putting this up, we need housing data, we need climate data, we need mortgage data, we need insurance data, and we need information about the demographics to answer the questions that we would like to look at. And so we've put these data sets together, and basically we're going to look at these questions in turn to try to understand what's different here and whether or not what we're seeing is reflective of this like framework. Go ahead.
So feel free to postpone this, but can you tell us a bit more about what the fires actually do to the land in the sense like, do you burn the flammable stuff and then the probability of fire is lower, or do they leave toxins behind or whatever?
Yeah, they do. They leave a lot of it. These fires are so hot, a lot of the toxins are burned. So it goes up into the wind, it goes way high and then is spread very far. But the land is scoured. I mean, there's nothing, it's basically sterilized, but it's a Mediterranean climate. And so things grow very rapidly. So post-fire, there's a lot of very quick, rapid growth. And a lot of the biggest problems are non-native trees, and they grow very, very quickly. So like the eucalyptus trees, the pine trees, some of them are not native, and then the palm trees. And they, again, are non-native. And some of this is, they grow both by runners and also by seed. And so the land gets scoured, then the rain starts, and the cycle starts again. It's been interesting. Some of the redwoods are quite impervious to fire. So they'll burn down to the trunk, but they store literally centuries of sugar in their core, and they grow new limbs. So my home burned in the fire, so I kind of know some of this quite well. They basically regenerate. So there was a huge redwood fire. It's called the Big Basin Fire in Santa Cruz. And the trees are totally regenerated. And in my neighborhood, the redwoods, you would never know they burned. And they're back within 5 to 7 years with limbs. It's pretty amazing.
Very interesting. But I guess for the diff and diff, we should think about, roughly speaking, both in terms of future fire risk and land quality of it kind of just being back to normal soon.
Soon.
Yeah.
The land quality comes back soon. And then you add these homes that are better than they were. It's like a mecca. It actually attracts people, and it attracts more development of the peripheries. And so these things keep coming back into the same place. Yeah.
Yeah, just related to what you're saying about the attraction to the periphery, I'm wondering about this kind of control group that's geographically adjacent to the treatment group, right?
Yeah.
What does that mean in terms of spillovers, right? So are people gonna, my house burned down, so let me try to move and stay in my same neighborhood and to like the control area, or like how do they?
So obviously it takes a while to build a house. So they're going to move, they're going to try to rent as close as possible. That often happens. But then because of this requirement, but how the policies pay out, they have to come back. So they tend to sort of stay as close as possible, and then move back into the neighborhoods. So that the redevelopment of these areas that are our controls are probably not by fire people. But all of the area is improving over time. And so the question is the relatives. That's what we're interested in. And well, you're going to see, we find that the inner control is the bigger recipient. It's the treatment.
So one question. Thanks.
Yeah, sure. Yeah.
This is the broader public policy question. So the sense I got from talking to a few people in California was that the right thing to do is that these regions have been identified. And there are like pockets of trees that actually need literally to be burned in order to reduce the wildfire problem for that entire area or region. And it seems all of this, in some sense, though, is negative for climate hazard in future in a way, right? Because if you don't fix the underlying propensity of the area to catch wildfire, but you get all of these effects that house prices are going to increase, house sizes are going to increase. Is it in some sense like the right response one wants? Because what one wants is to actually make the entire area sort of prone to wildfires, which requires actually coordination to destroy the primary pockets of
Fuel
leaks which are
source.
going to-
Yeah.
I'm just trying to understand, like, what is the broader public policy problem we are on?
So, I mean, it's a good question. I mean, because it is true, the trees and the vegetation all really matter. And the type of vegetation and trees, and it's a Mediterranean climate, so this comes back again and again. And that's why Spain is having so much trouble now, and southern France and Australia. I mean, we can list them out. But it's also inherently the topography and even grass, and even the way we build our houses. So another fire propagates along the ground. And so a lot of people think it's in the trees. It's not, it's on the ground. And so what we're finding is even our lots are quite small in California. So what do people do? I mean, I came up here on a train. They put partitions. What are they made of? They're made out of wood. So the reason Santa Rosa burned was because these fire ladders were their fences, and they just enabled fire to propagate across the line. And so as we learn about it, just like with earthquakes, we adapt and build differently and build lots differently. But I think it's an inherent risk in the nature of the way the Pacific Ocean is, the way the mountains are, and the way that temperature is increasing, and how much it dries things out, even the roof of your house. So sure, we can go some of the way. I mean, Berkeley's spending a lot of money to cut down eucalyptus trees right now, but it's not going to fully solve the problem. Maybe that suggests you shouldn't move to California because we have a climate that is very inducive to fire. Okay, so this is going to be a diff and diff, and so we're interested in these effects on the gammas and post-fire. And again, we'll have these control areas, and the definition of these control areas is by the scientists of the California Department of Agriculture that have been doing a really amazing job trying to understand how the fires start. Answer, for many of these fires, they have no idea. It's usually some kind of human intervention, some foolish thing that happened or random thing. And then what the periphery of the fire is post fire. Okay, so what do we see? So it takes a while to build a house. So these are the pre-trends. So this is the fire treatment on log houses. And as you can see, about 5 years after the fire, the houses are more valuable by about 5%. Yeah, go ahead.
Is a price here? Is that a transaction?
These are transaction prices. So what we're doing is we have a lot of events, luckily. So for every house, we basically build a repeat sale. So we're using all these houses, both burned houses and not burned houses, to build repeat sales at a point in space for every house, and then we're differencing. So we have those before fire events and those afters, and we're doing diff all the way through.
So in
Yeah,
some sense,
Johannes.
these are different, I mean, even if you rebuilt them sort of similar, it is gonna be a new house. Okay,
Absolutely,
so it's not the
which
same
is why,
repeat sales, it's like you have to
yeah,
take over the
exactly.
line.
It's a huge problem. I mean, just thinking of repeat sales, which all of us know don't handle that differencing properly. You can't.
It's almost by design.
It's
that they're
by
different.
design, exactly. It's by design. And so that's how we're measuring this, but at least we have a control in point of space for the treatment. And so this is the same for, now this is the treatment and control, those bordering, those also are capitalizing this improvement of the better built homes post-fire. And now we're comparing control 1 to control 2. So again, you see this externality again in these abutting areas.
Just to understand, so this is the relative increase of the stuff that burned compared to the outside, not the other way around.
Yeah, this is comparing control 1 to control 2.
Neither
So
of
the,
them.
No, sorry,
neither of them
even
burned.
Even the prior one said the one that the stuff that got burned went up relative to the, so the orange went up to relative to light yellow.
That's correct.
Okay.
And then we're comparing light yellow, sorry, I went too far. Light to darker yellow. And we see that externality is also capitalized into the houses.
And what's going on in the why?
So that's
Control.
also interesting in some of these areas. The data is from 2000 to 2015. We've now updated it to now. And many of these areas are growing areas. So there's development happening and often at the periphery, and those are the areas where there's still grass, there are still trees, and we see these fires associated with it. Okay, so this is square footage. After the fire, as you can see, there's nothing there. There's no house, it's gone. And you can actually see it in the administrative data because it goes to 0. The value of the improvement is 0. And what we see post-fire is that these houses are larger. They're built to code, they're better, but they're also their square footage is larger. And this, we believe, is again coming from this personality that's fungible. The insurance from that is put into the house, and these homes are actually larger. And then this is the same compared to control 2. They're larger again. And so where we are is these coordination effects are affecting house prices. Houses are more valuable in the fire areas, and the square footage houses are larger in the fire areas. So what's the effect on mortgages? Arpit, yeah.
Yeah, so maybe it's like a benchmarking exercise. I guess you could try just in general to ask if I have a home I'm next to that's new
Mhm.
versus a home, I don't know when this policy started versus a home that's old. What is the
yeah.
generic premium for being adjacent to like a new property or something
Yeah,
like that?
so I agree. Those exact things can happen. And I'm going to show you an out of sample thing in just a second. It sort of gets to that question. But yes, that's certainly a way that we could go forward to have this super clear about what these effects are for the improved properties relative to everything else controlled. All you have is the fire treatment, but everything else is the same.
No, I meant like leave the fire areas altogether. I'm in California and I'm near a new property that presumably has a lot of these improvements built into it versus I'm near an old property that probably doesn't. Is there just a generic externality that's placed into my house as a function of that? And does that magnitude compare to what you observe when you exogenously change the newness of these properties?
Yeah, one answer I can give to that, I do know, is because of what the California Department of Insurance, actually the California Department of Agriculture was doing, the houses that are newer are less likely to burn to the ground. So that's what the codes are giving us.
Yeah, but what about Arpit's house next door?
Yeah, exactly.
To the.
That
new
I
versus-
haven't done, but that could be done. And as we have more and more of these treatments, you can come and help work with me and we can figure this out. Hi, Indira, how are you?
So I guess I'm just have a clarification question, which is it mandatory to get insurance in these areas? And if it's not mandatory, do you think that the endogenous decision to get insurance is also affected by the fire? And if so, how might that play into this?
Yeah, so that's a really important question, and I don't have insurance policy. Nobody does, which is a huge problem. Most people, because this is their primary wealth in California, because the houses are so expensive, are insured. Not everybody, anyone with a mortgage has to be. And a lot of people have leverage on their homes, but many people do not. And our belief is, this is from the insurance companies, at the zip code level, is that about 85–90% of the people that own properties in California have insurance, whether there's a mortgage or not. But for any given house in our sample, I do not know. And unfortunately, no one else does. Yeah, Johannes.
So when a house with a mortgage burns down, the insurance pays out. Does the mortgage carry on the?
It does, it does. And so often there's forbearance for what it takes to build a house, which is usually 2 years. Or negative amortization. If you have a bad insurance company and a bad mortgage lender, you literally owe your mortgage payment at the end of every month over the building.
But also the mortgage lenders can't choose to drop it. They reinsure.
They cannot,
Structure
that's
A,
correct.
and you can
They
take the
cannot.
insurance money, pay off the mortgage, and you have to find a new mortgage to rebuild. So that's
Yes,
not-
but as I said, if they don't like the job you're doing in reclaiming the loss, because you're their agent, but the policy is paying off for you, they can intervene. They can actually require that the insurance company pay the money to them first, because they're first, on every installment on whatever it is you're getting for rebuilding.
Let's come back to this question of whether insurance is on every property or not.
Yeah,
My memory of the maps you showed 8–10 slides back, more than half of the properties didn't have a mortgage on it. For those, you just said 85–90% are insured, 10–15 are not insured.
mhm.
I would have thought you had a big enough sample that if you started looking at census tracts, you could start seeing patterns of whether things are insured or not insured.
So the insurance data are
So-
available by.
Mortgaged or not mortgaged, and make some inferences.
Oh,
about
yes,
it.
we know which ones are more, I'm gonna show you that in just a second. So we know the mortgaged and not mortgaged properties. Oh, we know all of
I
that.
thought you had said.
No, the ones that have insurance. Indira asked me a question about insurance policies.
No, I
house
thought you
by
said
house.
Nobody knew something about.
So
insurance.
nobody has the policy data.
Oh, the actual details.
Exactly, like which house has
But you
which
know-
insurance
but you know-
company and to what magnitude? Is it guaranteed replacement? Is it replacement? You know, all these little nuances.
But you
But do
do know.
you know whether they have some insurance? at the property
We do
level?
not have the property level insurance data. We know if they have a mortgage, and if you have a mortgage, you have to.
But for someone who doesn't have a mortgage, you cannot pinpoint.
You
whether
cannot
they-
pinpoint it. The best you can do is at the zip code level, fractions. That's it. Zip codes are kind of big. Okay, so what's the effect on the mortgage market? Well, given what I just said, the protection is for the insurance, for the banks.
Sorry, no, I want to
Okay,
go back.
right.
You said zip code, and gee, census tracts there are a lot more census tracts than there are zip codes. And
So we know we don't have the data at the census tract level for the policy data.
but you know the properties.
I know the property that long. So I know a lot about the properties. I know
At the census tract.
in the census tracts.
Yeah.
But I don't know the policy.
I understand
Okay.
that, but again, and you will also know which are mortgaged and which are not, because you can have
Yes,
the mortgage.
And that's what I'm
at-
doing.
At the census tract.
Yeah.
So you can start looking at different percentages that are mortgaged across different census tracts and start making inferences about, gee, I've got a lot of unmortgaged properties here, I have fewer unmortgaged properties.
Sure, we
there,
can do that.
And start making inferences, I would think, about insurance coverage.
But I don't know the I don't know the policies. I don't
So
know
the
what
idea-
they
I
look
think
like.
what Larry's trying to say is
I know they
We
might
use
have
whether or
it.
not there's a mortgage as a proxy for whether they have insurance, under the
I'm
assumption that.
already doing that.
Okay,
All right, thank you.
So thank you. So that is exactly what we're doing. We know if you have a mortgage, you've got
For sure,
insurance.
for sure.
End of story. So I don't know all the details, but I see the details and I'm seeing them rebuild giant houses on top of that policy. So I know quite a lot about what the payouts are on these things. And we know the numbers and we're talking huge numbers. And every year kind of numbers we're doing, which is why Allstate and State Farm are saying, we're out of here. We're not doing this anymore. Yeah.
Just
Arthur.
one more quick follow-up on
Yeah,
this.
sure, go
So
ahead.
just to make sure that you've probably already done this, but the price spillovers then are larger, or have you tested them if the neighboring property that burned down has a mortgage, right? Because that implies it has insurance and there was built,
That's correct. Yeah, we're controlling for all of that.
No, but you then find that the spillover in prices.
Ah,
of
that's a
neighboring
good question.
properties-
Actually, no, we haven't done it that way. No, that's a good question. No, that's a really good idea. That could easily be done. Yeah, yeah.
So you have a sense that insurance companies are just losing money hand over fist in this area. And then where is the cross subsidy coming from?
So right now, I remember there's also the time series of all of this. So the problems are becoming more severe. I'm going to show you in a minute why. And so I think like we're going back to 2000, so we have 16 years of data. And on average, it's very recent. So the biggest problems have been very recently. And that's where the insurance companies are saying, this has changed, we can't do this, and so we're gone. And I think that risk is forecastable, and I think they're justified, and I think we need to think about how we do diversification, a lot of other things about how we think about these risks. Okay, so this is the mortgage market. This is all terminations. And so this is both prepayment and default. And again, we don't see much here post-fire. And this is the same. This is prepayment. We don't see a lot of prepayment. It'd be hard. You don't have a house.
Prepayment, if someone took the money and moved somewhere else.
They
that
would
seems
have
like
to
a prepay.
prepay.
So this
They would
basically
have to
is data
prepay.
that nobody does that, they all. prepay.
No one does that exactly. So you're forced to stay in the same place by the law, not since 2022 when this proposition was passed, but you would have no incentive to prepay. And interestingly, or default. And so we see virtually no default, which is quite interesting. And again, looking at the treatment versus control in terms of who's living in these houses. So we have the data of who lives in every single house. Yes, go ahead.
So is there no default because of the forbearance? I'm trying to see, like, even if you know the house will get fully rebuilt, I'd
Mhm.
imagine after a fire, some people have a cash flow crunch.
They do,
where
but
they'll
don't
get
forget,
30 days past due or 60
with
days.
it, I agree, you do, but most policies give you a living stipend.
Okay.
So you are getting a draw on a monthly basis that pays for your accommodation. And so sure, I mean, you could be totally traumatized. I mean, there are a lot of things that could go wrong. I could imagine there'd be some, you'd be inclined to default, but as you can see, it's not very much.
Local unemployment because.
Yeah, so that's another, that's correct, but a lot of this is, I'm looking at residential. We're about to do commercial, which is another whole big issue. So even measuring what the economic effects of these fires has been, that's the local unemployment. These numbers are all over the map from like 2050 to 150, what the overall cost all in terms of loss of jobs, loss of employment, etc. We don't really have good numbers for that. Okay, so what we see is this is again the pre and post fire. If anything, people are a little bit poorer after a fire. There's basically nothing going on. There is not gentrification, either for the control 1 or the control 2 relative to the burned areas. So basically, this is what we see. We see bigger houses. Yeah, go
How
ahead.
do you measure the income percent?
Okay, so these are looking at, this is using the data Axle data. So this is marketing data. It's like in Footer. These are data, it's sampling data. It's not great. It's the best we can do. But what we see is we see every house. We see transitions from these houses. Everything is merged to these houses by address. And I'm looking at who lives in that house over this period of time.
Do you think the drop in income is coming through a change in the people who are living there? That the people who live there have slightly lower income, or could be that the people who live there and are staying there are somewhat having a drop in income? But you could think of like, I'm working less overtime or.
It could
things
be
like that.
any of those things. Both of these data, we just expanded this a little bit to try to get absolutely everything, not just houses with mortgages, but every single house. And that's where we see this like change. With the houses with just mortgages, we see nothing. But this is all houses.
Or you could think like, now I have to plan my new house, so I think,
Yeah.
you do fewer extra stuff.
Yeah, all of it could be true, but the actual reason for this, I'm not quite sure, but we don't see lots of rich people taking these properties over and moving in. And I'm going to show you again something out of sample where again, we see this and it's just like right now happening. All right, so now what's the expected loss here? So this is sort of thinking of how do we think about the mortgage balance sheet on the bank's portfolio. And we're going to carry out an in-sample exercise on computing the property-specific measures of wildfire risk, very similar to what you would do in expected losses in the mortgage market. And so we're going to, for every house, we're going to collect all of these environmental data to look at what the propensity for fire is at a point in space. And then we'll map all the houses onto the point in space and ask the question, well, what's at risk here? And we're working on forecasting models. This is in the cross section, but we're working on forecasting models right now to actually think about forecasting this out of sample. And we've made some nice I almost thought about showing you these, but the progress is there. This absolutely can be estimated. The California Department of Insurance is just completely off base in terms of not allowing these models. Yeah.
I'm not clear what you're measuring here. Is this simply the loss in the capital stock?
Yes.
Oh, okay.
So if you are a bank and you had an exposure to this capital stack.
Except it's insured.
Exactly.
So
It's
the ultimate
insured.
loss is to the insurer.
Exactly. And that's basically getting back to this question. Is this a forecastable problem? Because this is the insurance company dilemma vis-a-vis our regulator. And then what's the magnitude of this problem? And can we diversify out of this problem? Probably not. These are fat-tailed risks. How do we solve this problem? And right now we don't have a solution yet.
So when you say the regulator doesn't
Allow it.
this pricing, is this like this pricing fixed by the regulator?
Yes, the
So
policy.
the insurance company can basically decide whether to participate in the market at the fixed prices or drop out.
That is correct. That is exactly the choice that the insurance companies have right now. So right now in California, up until, yeah, up until last October, you had to use the 20-year average fire probability as your pricing model. And I'm going to show you graphs in just a second. Max temperature is going like this. And most of this is driven off these temperature fluctuations, given the topography of the state. And again, so that there really is a proclivity to fire that is baked into the way the earth is structured, and it needs to be priced. And they do not allow this. And if you look, there's a recent New York paper by some economists at the Fed, and they find that our insurance rates in California are the second lowest in the country. Yes.
Brought this up in several settings, and I'm still not getting the point of the regulation. Is it just fear of price gouging by the?
It was a proposition that was passed in 1989. And Ralph Nader was the designer of the proposition. And the basic idea was that you could deceive consumers using probabilistic models. And therefore they should be significantly curtailed. And that using long-term averages were fair for consumers. The other thing that is prohibited in California, including now, is you can't reinsure the tail risk. So you can't include the rate structure of reinsurance in the primary market. So those two features, no actuarial models, no use of the rate structure in the reinsurance market, even though casualty fire risk is now unbundled in the secondary markets, has devastated our markets. So it's very short-sighted. I wrote a grant, and Drew knows about this. I wrote a grant last year and I had to promise not to look at pricing. I actually signed that paper. I didn't get the grant. I'm still trying. But yeah, that's how it's extreme.
Yeah.
This is in one of the largest states in the country, and it's like 50% of the mortgage market. It's 50% nearly of Fannie and Freddie's portfolio.
Can the insurers exit house insurance but still say
Yes.
stay as auto
And that was the big problem with earthquakes. We solved that with the earthquake insurance, special mutual. And we have a mutual for fire insurance, which is called the California Fair Plan. It was never designed to be permanent insurance. It's very expensive and it's not full coverage. So that's where these people go. But it's just checking a box.
but the insurers can stay in the auto.
That is correct. And they're taking advantage of it now. All right, so we're going to look at this, and this is the biggest problem. Max temperature is definitely rising, and it's very persistent. And this is, anyway, we won't have to debate this. Estimating these models, this is in the cross section. As I said, we're working on out of sample, and we're actually having some luck. And what you can see is there's a big intercept, which should make you worry, and that's been our focus of improving that. So the weather characteristics are hugely important: wind speeds, relative humidity, and then the other key thing is the winds. Whether there's a low pressure zone over the Pacific Ocean and a high pressure zone in the interior, such the winds go from the east to the west, because these go up the slopes of these ranges, they hit the crest and come down in superheated at very high speeds. And so
come off the Pacific Ocean.
nearly always, that's why there's so
from the
much
west.
fog. We go from the west to the east, bringing hundreds of tons of water at the same time and dumping it on the ground. But in the summer months, starting in August, usually June, August, September, October, now November, we get different, it comes from the east to the west. And it used to be not considered dangerous. So there are two winds. There's the northern wind, there's the southern wind. The Santanas have been long considered dangerous. Too bad Rob isn't here, because this is what burns down Southern California. And now the Diablos, which were considered 100-year events, are now annual events, and they're much more dangerous than the Santanas because of this pricing problem, that houses are in the wrong place. At least there was some recognition of this in Southern California. And then the other thing that's really important, as you can see, is slope and elevation. We're measuring the slope by every single that long, and then what kind of vegetation is on the ground, and then the seasonality. But the seasons are getting longer, and so again, we're trying to get this forecasting, and so that we can forecast out of sample. That's not this exercise. So what are the expected losses? And again, this is on the stock. And so we compute what the stock is. This is for 2020. And basically we add this all up, and the sort of the high line feature here is This is the annual expected summer loss is about $20 billion. And we've already had 3 years where there were literally the summer was $22 billion with less than 4 fires. And that's what's driving the insurance companies out of the state.
These are millions or billions?
These are billions.
Because it says M at the top.
Oh, sorry, sorry,
These are billions.
there.
Okay.
Okay, so these are the graphs. We've taken the concrete part out, which I was asked about, because what you see is this is where all the concrete is. The real estate is really expensive, but the probabilities are really small. And so again, very high risk areas and major areas around these cities that burned down. Berkeley almost burned down in 1991, but they were able to stop the fire. Okay, so I believe these are regulatory distortions. I believe the California Department of Insurance is going to have to start pricing this risk. And I believe that we all have a lot to help them with in good measurement and making the contracts correct and making them tied to the actual risks on the ground. Arpit, yeah.
So what would be the consequence of shutting down all insurance markets? So they all, all leave because they can't price accurately. So people that have to self-insure, right,
Yeah.
this risk, obviously, so they'll have to bear that 20 or so odd $1 billion themselves. So you've outlined one clear problem with that, which is they're not incentivized to rebuild in an effective way, and then that has consequences for other people that's not internalized.
Mhm.
Are there other like subsidies or other requirements or mandates that could replicate the benefit of rebuilding in a world in which everyone still self-insures and you just don't have insurance markets?
I'm not sure, I'm more, it's a possible way forward. I'm more thinking non-parametrically of thinking about like, how do we reinsure tail risk? How do we do tsunamis? How do we do earthquake? We start thinking about gradients relative to centroids. And so basically kernels. And I think that's where it's going. Instead of saying, okay, I'm going to go look at your house and indemnify you personally for all of these things. We're going to set up bond markets that have to do with these high concentration areas. We'll securitize them. We'll get a bond market that's functioning, hopefully derivatives on that. We already have that. We have options and futures in the reinsurance market, and they actually work. They're not your grandmother's insurance. They're not like, that your house is going to be rebuilt, but with some positive probability in areas, you'll be compensated. And the markets could be made liquid, or at least as liquid as we can get them, because right now they're not.
It just seems like that'll happen in other states. Oh, sorry.
Give Nancy the last 2 minutes.
Yeah, so I want to show you this out of sample. I've been hinting at it. So there was a whole city that burned down in 2018. This is Paradise, California. And just now there are no requirements to build in the same place anymore because Proposition 19 took care of that. This is the background probability at a given node. There are 2 nodes that define Paradise, is about 78 basis points. So very unlikely at any point in space that you'll have a fire. Paradise, which is the northern dot, the probability of wildfire there is 5.6%. And the southern node, the probability of wildfire there, given where it is on the slope, given the vegetation, the forest, is about 2.5%. Okay, there were 9,700 homes burned. And right now, 80% of them burned to the ground, so they weren't habitable. And right now, today, of these total, 2,900 applications for permits have been granted, 27 permits have been issued, and 2,042 occupancy permits have been, people have already moved back in to exactly the same place where they were and rebuilt their home and used the insurance policies exactly as I'm representing it right now. And this is a place that the entire city, including the downtown. And of course, the downtown is on a revenue bond. So the municipal bond market is now affected, as are all the University of California's, by the way. They are all funded off munis. So this has big implications. And again, the basic bottom line here is this is estimable. These are measurable risks. They need to be insured. We need to figure out new ways to do this. And obviously the California solution is not sustainable. And if anything, the news this week just reinforced that. So I welcome all of you. We have a lot of data. I welcome you to join forces with us and try to figure this out.
What's the news this week?
Allstate just
Oh.
informed us that upwards of 70,000 policyholders were going to lose their policies in the next 3 months. Thank you very much, and thank you.